Hello, I'm Bill Fournier, here to talk to you about ATI and Honor Code's Requirement and Development Management course. It's a 3-day course that gets into a very detailed thing on probably the most important part of system engineering, getting good requirements. The course objectives. We'll talk about how requirements are used in system and product development and their nature of requirements and the challenges that they have both in making sure they're correct, in allocating them, in analyzing them, etc. We'll learn sources of requirements and how to develop a specific requirement for each. Sometimes the source is the end user, sometimes it's some other stakeholder, sometimes it's what industry has available. We'll learn different types of requirements like performance or functional or a couple that we deal quite a bit with and how we deal with each of them. We'll learn how to write effective requirements, each type, that have appropriate standards that we can deal with, that are legally and contractually binding, that really trace back to what the user really needed. We'll learn how to analyze a set of requirements for clarity, cohesion, completeness. Understand how system requirements can be allocated, decomposed into implementable component requirements, and learn the information that we should need to help manage those requirements from a traceability, from a configuration management perspective, etc. This shows the schedule for the 3-day course. It has an overview, number of texts as we kind of look at requirements through the requirements lifecycle, which is a very key part of the system engineering lifecycle. Early on, we define what the stakeholder is, etc., and the stakeholders. And we have the various types we talked about, and we'll be defining them, writing them. You'll be doing some exercises. We get to practice these skills because it can be very difficult for a complex system like ground-based mid-course defense at the system level had 1,000 requirements in its technical spec to get all of them correct and everything. We'll deal with requirements analysis and requirements management in the 3-day course. And we'll use an exercise where you get to practice them. Because you look at real life requirements and they are very challenging to write them in an appropriate way to trace back to what the user really needs and also to what the supplier can provide in a reasonable time frame and cost and risk perspective. Talk about what is a requirement. A desired attribute of a system. It can be its size, its weight, its power, many other things that are attributes. Formalized statements that identifies a capability. Why do we use a formalized statement? Quite often we're going to put these requirements for the system on a legal document that has a capability, characteristics, and quality factor. It has a way we can measure that eventually the supplier delivered something that met those requirements. The system, in order for it to have, has to have value and utility, and some of that is, let's say for ground-based mid-course defense, was those 1,000 requirements, do they help in this case, the United States defeat ballistic missiles coming from rogue nations? Ground-based mid-course defense main requirement was, and those 1,000 requirements that were in the spec. To a user, in this case, the user was the DoD in providing that and field in that system to defeat rogue nations firing ballistic missiles at the US. One of the challenges of requirements is they're so critical to system engineering, and the chaos report that came out showed that over half the problems with systems were traceable to requirements. And that we had considerable overruns in many systems in cost and schedule. And the average overrun, you can see the figures there, was very high. And requirements are directly attributable to these problems that the chaos report mentioned. The user involvement. How do we get the user involvement all the way through the life cycle in dealing with the requirements? The user just wants a new system to do a certain function and provide a capability. But in order to do that, quite often there's a lot of debate over what all the requirements are and how tough they should be and what's reasonable within the cost and schedule and other constraints. How do we optimize those requirements for the scope of the contract? And how do they tie to clear business objectives from a commercial thing or clear mission objectives from a government perspective? This shows how requirements fit into our system engineering model over the life cycle. They're involved real early in operational definition, defining what the user thinks they need, quantify the need, and then a concept of how the new system that is eventually going to be there is used by the user in order to meet their business or mission objectives. Stakeholder requirements. Requirements definition, convert those operational things like a requirement that might say to be friendly, user-friendly for software might become a Windows pull-down menu. In building software might be a way to do that. But there's various options. Capture constraints like these. Does it have to fit into an aircraft carrier or a box or a building? Does it have to use standard batteries, etc.? Might be requirements definition stuff. We do requirements analysis. We look at those requirements to see how do they fit into the technology and the risk. How do they fit together? How do they fit into what's available in the time frame that we're talking about? We look at architecting and designing the system. We come up with an early concept for how the system might function, might have subsystems, and how those subsystems might work together in order to meet all those requirements. We get involved in allocating requirements in how much of the cost, weight, power, etc. Each of the subsystems is allocated. And we try to do that to balance out the risk. We eventually get down to the bottom of the system engineering V, where we get involved in the specific detailed product design and the implementation of that design. And we have to make configuration management, handle the inevitable changes, and to look at their impact on all the requirements and how they all fit together, and iterating that design as we go to various levels of design. We have to do system integration. We have to put all those pieces, parts, components, subsystems together to create the system. And these requirements become a basis for doing that integration, to seeing that we put two parts together, that we actually get what we expected. And for proving out, delivering the system. We want to prove out it through tests, analysis, demonstration, inspection, verification, and validation that these requirements that we had in requirements definition as system technical requirements, verification, we prove out we objectively met those. In validation, we go back to the need, and we try to prove out that we give the customer, user, that what he needed, or did it change along the way, and we didn't quite do that. So we do requirements all the way through the life cycle until the system is delivered to the user. All the way affecting these various parts of the life cycle, from operational definition to requirements definition to system architecture, we come up with concepts and later on lower level concepts, to design and integration and test. We have to have various contractual, baselining, and risk things that we deal with for the developer from the acquirer's perspective. And from the developer's perspective, if the developing system engineer has maybe subcontractors under them or other teams under them that he's allocated requirements to, and how does he deal with that? When do we baseline certain pieces of our system as we go down later? That's pretty much what it is. I think this is a really valuable course for any system engineer, for test engineers, for design engineers, in order to understand requirements and what makes good requirements and be able to build, allocate, and eventually test these requirements. Thank you.